It's Friday. Today we're going to go ahead and review all of the forms for solving a quadratic. I actually got my printer to print, so we'll be able to do this on paper, and then your homework will be on Delta Math. Alright, so what I'm going to do is I'm going to start out with square roots first because it's the easiest one to spot. So square root is when you have that bx term is missing, and I'll post these notes on Canvas if you want to print them out as well. But you're going to have that no bx term, or it's going to look like some x plus some number squared equals some number, or something like that. So it's going to have specifically that parentheses and that squared. So I'm just going to look through this list on the side and see if any of them look like that. So looking here, I see an x term, looking here, x term. Oh, this guy is in that parentheses squared, so I would divide by 2 and I would solve. I'm not actually solving here, I'm literally just going to say which method I'm using, and we'll solve on the back. Alright, so I would use the square root method. Alright, moving on down, I see an x term, so can't use it there. I see an x term, so can't use it there. Oh, but right here, I see no x term. So I would divide by 4 and square root both sides. So this would be another square root method. You can always solve every single thing by completing the square or quadratic, but if you're able to do square root, it is the easiest method on the ones that it's actually applicable for. Okay, moving on down, I see an x term, I see an x term, and I see an x term. So square root method only works for 2 of these, but it is actually the best method to use on those 2, so I would definitely use this first. All right, the rest I'm going to do together, and we'll just look at each of those questions separately. All right, so factoring, if it's missing that c term, meaning it only has an x squared and an x, that's when it's super easy to factor, or, ironically enough, when it is factorable. And how do I know when something is factorable? If the discriminant is a perfect square. So on all these problems, I'm going to, firstly, if it's factorable just as is, with missing the c term, I'll go, yeah, cool, let's factor it. Otherwise, I'm just going to quickly find the discriminant, that b squared minus 4ac. If it's a perfect square, I'm going to factor it. If not, I'm going to either complete the square or do the quadratic formula. Now, both of these methods work all the time, but completing the square works best if the a term is 1, because then you don't have to divide all the stuff, and if the b term is even. Because don't forget, when you're completing the square, you take that middle term, you cut it in half, and then you square it and add it to both sides. So if you already have your a term being a 1, so there's no division required, and that middle term's even, then completing the square is not bad at all. So I would definitely do that method. And then lastly, quadratic formula always works. And it's actually best just to jump straight to this method if your answer is going to be messy, or if you have crazy large numbers or decimals or whatever. So quadratic formula always works. You could literally quadratic every problem on here except for the ones that have this parentheses squared thing. So that one you would not use the quadratic formula, but literally everything else, if you wanted to, you could. So in the end, by default, if that's what you want to do, and I do have students who literally quadratic everything. And on a test, it takes a long time sometimes to quadratic things that are not messy. Like if things are easy to factor, it takes longer, but do what you want. We're obviously not having a test in this class unless we come back on the 27th or whatever. But to save yourself time, don't always quadratic everything. Okay, so now that we have that in mind, keeping in mind that the discriminant tells us factorable or not, and then if it's not factorable, you may want to complete the square or quadratic it depending on how those numbers look. Alright, so jumping up here to the top, I have x squared x. Oh, I have no c value. So actually this guy is very easily factorable. So I'm going to factor this guy. You would just factor out an x, leaving 2.1x plus 3 equals 0, don't forget, and then you would set x equal to 0 and set that equal to 0. So don't forget, factoring is super easy, and I could be done that in seconds flat, way quicker than doing the quadratic formula. Alright, look at this next guy. He's not just completely obviously factorable, so I'm going to find the discriminant. I'm going to do b squared, so parentheses negative 6 parentheses squared minus 4 times a times c. Just typed that straight in. So I'll put it right here. Maybe you can see that. So there it is. Boom, press enter. Oh, 16. 16 is a perfect square, so this guy is factorable. So I would, for myself, I would choose to factor that. What multiplies to be 5 adds to be -6, so that'd be x minus 5, x minus 1, and I'm done. So that guy would be pretty easily factorable. All right, moving on to the next one. Again, not completely obviously factorable as is, so I would do the discriminant. So I would do parentheses 6 squared minus 4 times a times c is -12. Boom, 84. That is not a perfect square, so therefore it is not factorable. So I have to either complete the square or quadratic. If I have to pick one or the other, this one has a 1 leading coefficient and it has an even b term, so I actually would complete the square. But again, it's completely preference. If I'm not forcing you to do one method or the other or to use each method once, you can do whatever you want. But I would complete the square there. Okay, next one. You would need to get it moved over. This would end up being a -48 equals 0. It's not obviously factorable. If given the option, I would definitely not complete the square. This guy is a 5, so I'd need to divide all terms by 5. I'd have 11/5 and then have to cut that in half. That's just a mess. So if it's not factorable, I would go ahead and just quadratic, and I'm assuming probably already it's quadratic, but let's go ahead and prove it. So b squared, so 11 squared minus 4 times a times, and c is now -48. This is 1081. I don't think that's a perfect square. I'm just going to square root it real quick. No, not a perfect square. So therefore this guy is not factorable. He's going to have irrational answers. I am not completing the square on this guy. So he would be a quadratic formula. Terrible handwriting, that's okay. All right, hopefully you're understanding what the process is here. Square root method, easiest to spot. He's always just missing that x term, or he has those parentheses squared. So he's the easiest to spot. He's one that you for sure want to use if you can. Beyond that, I prefer factoring, but if you did not do super great at chapter 7 and you're not a great factorer, then obviously you might want to use quadratic formula on everything. All right, this guy here, just looking at him, he's probably not factorable, but I'm going to go ahead and say b squared minus 4 times a times c. Boom, 384. That's definitely not a perfect square, but I'm going to double check. Not a perfect square. So on this one, you could do actually either. I see that this guy's a 6, and we want to have a 1 out front, but if I divide this by 6, I'm going to get a 2, so it's not too bad. So this one you could do whatever you wanted. Most of you guys would probably choose quadratic formula or maybe complete the square. I would, if I was required to pick one or the other, I would probably pick complete the square just so I could get that option out of the way, but either one's fine. Okay, here, make this a -16 equals 0, just move it on over. Probably not factorable, actually 8 and 2, yeah, definitely factorable. Okay, so to prove it though, I'm going to find the discriminant. So I'm going to say parentheses, -6 parentheses squared minus 4 times a is 1 and c is now -16. 100, perfect square, which means this guy is factorable. So as soon as I said out loud, I saw that 8 and 2 would work. So that's easily x minus 8, x plus 2, answers 8 and -2. Done. Like you could be done in a second. And it took me just 1 second to plug it in. Not too bad. All right, this last guy's actually got a y equals, and we haven't gone over the graphing section yet. We don't actually use graphing to solve anything. We mostly just check our answers with graphing. So if you wanted to, you could graph this guy or just literally go boop, make it a 0 and then do what you want. And I can already see that 6, what multiplies me -6 adds me 3 is going to be factorable, but I'm going to go ahead and say 1 squared minus 4 times 1 times -6. 25 is a perfect square. I would factor this guy. He's going to be x plus 3, yes, and then x minus 2. Okay, so there's that guy. And then this last one, obviously you would have to look at graphing, but to solve for the roots, you would literally go, oh hey, -3, oh hey, 1. So this guy would technically be graphing, but you already have it graphed, you're just looking at it with your eyeballs there. So the whole point of the front side of this notes is just to remind you the methods and to know which one to pick. So on the back side, and we'll get this done in 15 minutes, I promise. On the back side, we're just going to try to do as many as we can and choose the best method. So on your Delta Math homework, when you are choosing which problems or which way to solve it, try factoring first by doing the discriminant, but if not, you can always just quadratic everything. All right, so we'll just go straight through, no big deal on these answers here. So this one, I see that I have an x term, so automatically I cannot do square root method, but I'm missing a c term, so I can actually factor. So I'm just going to factor out an x. Well, actually, I'm going to factor out negative x, so I can get that negative on the outside, leaving 16x minus 3. Now, set equal to 0, set equal to 0, and you're done. That's going to give me x equals 0. If you add 3 and divide by 16, you're going to get x equals 3/16. Boom, finished. That was easy. You could have done it in quadratic formula. It would have just taken you longer. All right, looking at this next one, it's got a lot of stuff there. Definitely not square root method because I have an x term. I probably can't factor just easily because there's a c term. I would not complete the square for sure. So I could do discriminant and then discover that it's factorable or not. So I'm just going to go ahead and do that real quick. So I'm going to say parentheses negative 5 squared minus 4 times 8 times 10. Oh, the discriminant is negative 295. So what does that mean? If the discriminant is negative, it means no real solution. So that guy's done. So doing the discriminant made that question super duper easy. All right, we got 4 minutes. We can make it. All right, this one here. Again, I would always check for square root method first, just because it's the easiest to spot, and it's spottable by having either parentheses, like this guy's clearly square root method, or you're missing the x term. So, oh, this guy's missing his x term, so I would do the square root method, and I'm going to do that by dividing both sides by 5. Okay, and then, sorry, that's a terrible looking 8 there, and then I'm just going to square root both sides. I'm going to get absolute x equals square root of 8 is square root of 4 times square root of 2, which is 2 root 2. Don't forget, you always should get 2 different answers, and because it's got a square root on it, I can just go straight to it. So positive negative 2 root 2. While I'm at it, since I already identified this bottom one as square root method, I might as well go ahead and do it. So this guy is square root because he's parentheses squared. That's the only method you actually can use here. So I'm just going to go ahead and square root, square root. I'm going to get absolute 2x minus 5 equals square root of 20 is 4 times 5. So square root of 4 is 2, square root of 5 is the same thing. Because it has a radical, I can do that positive, negative, and then I can just solve this guy in one fell swoop. So I'm going to add that 5 over, and then I'm going to divide by 2. So I'm literally just going to divide everything by 2. So 5 plus minus 2 root 5 over 2. And that's it. That guy's done. All right, we got 2 more here. All right, this one here, looking at number 4, he could do really whatever. I can't do square root method though, and I can't factor just as is, like just looking at it. So I would need to get it equal to 0 so I can see what I'm doing here. And I would just check the discriminant real quick. So parentheses negative 12 squared minus 4 times 2 times negative 10. It's going to give me 224, and that is not a perfect square. So you can do whatever method you want to. I'll go ahead and just complete the square just so we can practice that one more time. So divide everything by 2, and I'm going to go ahead to save time, just move this guy straight over, so he's going to be a positive 5. So I'm going to add the same thing to both sides. I'm going to take this guy and cut him in half, so he's going to be a negative 3 squared and a negative 3 squared. This left side is going to be x minus 3 squared. This right side is going to be 5 plus 9, so 14. Square root both sides. I'm trying to save time. I got a couple seconds left. Square root of 14 is just going to be stuck, so positive, negative. To solve this, I would add that 3 over, so x equals 3 plus minus square root 14. Okay, I only have 30 seconds left, so this video is over. Can we do this last guy? Discriminant, I'm just going to go ahead and tell you is 1. So this guy is actually factorable, so I would go ahead and factor him. What multiplies to be 6 and adds to be negative 5? Boom, boom, boom. Well, it's negative 2 and negative 3. So x minus 2, x minus 3 equals 0. Therefore, x equals a positive 2 and a positive 3. I made it. All right, go do delta math, and I'll see you guys tomorrow.